Emert International was tasked to relocate a reactor pressure vessel, or RPV, that had been removed from service at the San Onofre Nuclear Generating Station. The RPV had been placed into a cask, grouted, and stored at the facility for approximately 20 years. The RPV cask measured 47 feet 7 inches long by 15 feet 5 inches wide by 19 feet 3 inches tall and weighed 1,470,000 pounds. The goal was to remove the cask from its existing staging area, transport it to an on-site rail spur, then transport the RPV cask by rail to Las Vegas. At Las Vegas, the RPV cask would then be transported over the road to a decommissioning facility in Utah. Given the RPV cask size, a multitude of rigging challenges were overcome during the relocation process. Several items had been constructed around the staging area. The spent fuel storage area was to the south of the RPV cask. To the north and east, concrete barrier walls had been constructed with a 5-foot increase in elevation on the other side of the walls. To the west was a concrete wall that served as a barrier to a spillway. Any open areas were lined with concrete barriers. To address the confined area, Emert International recommended lifting the RPV cask to an elevation that would accommodate placement of a hydraulic platform trailer under the piece. To accomplish this, Emert designed a lifting system that would not only support the 1,470,000 pound RPV cask, but also have a wide enough clear span to facilitate the placement of the platform trailer under the cask. The lift system consisted of 2 large header beams that were placed at each end of the RPV cask. Each header beam had 2 27-inch I-beams, welded together and reinforced with plating and gussets. Emert International constructed 8 D-rings that would slide over the outside of the header beams and serve as the main support point for holding the RPV cask in the air. Below the D-rings, Emert designed and constructed the lifting links and pins that would fit into the pre-cord holes at the end of the RPV skid frame. The ground loadings were also taken into consideration. A reinforced concrete pad had been put into place for staging the RPV cask. However, the surrounding area consisted of standard paved asphalt road surfaces. As a result, Emert International placed over 100 pieces of steel plating throughout the area. Because of the security fence to the south, barge ramps had to be positioned at an angle along the fence line to prevent any interferences. In addition, the rear header beam had to be offset to the north so it didn't interfere with the security fence. The width between the RPV cask and the north wall would not accommodate the width of the platform trailer. To address the width of the trailer, Emert installed 8 100-ton hydraulic jacks at lifting lug points at the base of the RPV skid. In addition, 8 5-inch spacers were built to fit on top of the jacks and would nest into each of the 8 jacking lugs. The RPV cask was lifted approximately 2 feet and a slide system was installed under the RPV cask. After lowering the piece onto the slide system, the RPV cask was then slid to the south approximately 5 feet. After sliding the RPV cask to the south, it was then lifted to an elevation of approximately 7 feet, which required a different jacking system. Emert International designed and fabricated 8 100-ton climbing jacks to lift the RPV cask. Once the RPV was elevated to a sufficient height and the area was cleared, Emert International utilized a crane to place the header beams, rigging and dunnage around the cask. The pins were installed into the RPV skid and secured. Emert then began to slowly lower the climbing jacks until the weight of the RPV was fully supported by the header beam configuration. Emert was now able to position the Goldhofer double-wide 12-axle platform trailer under the RPV cask and utilize the hydraulic trailer to elevate and support the RPV cask. The Emert trailer operator had less than an inch of clearance on the west spillway wall. At the front of the trailer, there was also less than an inch of clearance from the angled barge ramp. Upon transitioning the RPV cask onto the platform trailer, a crane was again utilized to remove the header beams, lifting links, D-rings, staging stands, and barge ramps. After removing the RPV cask from the staging area, Emirates International was required to transload the RPV cask from the double-wide 12-axle trailer to a double-wide 16-axle trailer. To accommodate the transload, the hydraulic platform trailer was elevated to a predetermined height. A crane was again utilized to set all of the support equipment, including the header beams, D-rings, and barge ramps. At this point, the RPV cask was supported by the header beam, and the clear span was sufficient to change out the trailers. The RPV cask was then transported to an on-site rail siding. Emirates International and the client had intended to use the trailer to spot the RPV cask over the railroad tracks and then lower it into position so that it could be connected to the KRL 3600 Schnabel car. To accomplish this, some minor excavation needed to occur on the west side of the rail spur in order to provide sufficient room for the barge ramps. However, the on-site environmental agency indicated that the area to the west of the rail siding was home to birds that were listed on the endangered species list. Therefore, no excavation was allowed at the rail siding. To address this issue, Emirates' engineering team went to work on a new solution. They proposed closing the road on the east side of the rail spur and using this area as the offload site. After offloading the RPV cask, Emirates International would then jack and slide the RPV cask into position on the railroad tracks. Closing the road entailed restriping the roadway, utilizing temporary traffic signals, and changing the entry point onto the Pacific Highway. Nonetheless, Emirates was able to incorporate all of these elements to redirect traffic and successfully offload the RPV cask next to the rail spur. The interface between the RPV cask and the KRL 3600 Schnabel car required additional components. Specifically, a steel framework was installed at each end of the RPV cask. An H section was then mounted to each of the steel framework sections. The H section would connect to a compression frame, which was installed on each end of the KRL 3600. An engineered torquing procedure was followed to make certain the contact point between the Schnabel car and the RPV cask was secure. At this point, the loaded KRL 3600 Schnabel car was ready for transport to Las Vegas. A new rail spur was constructed to offload the RPV cask at the starting point for the over-the-road portion of the project. Emirates International designed the spur to accommodate the offload of the RPV cask from the KRL 3600 utilizing the same header beam, D-ring, and lifting link configuration. Upon arrival of the rail car, the RPV cask was offloaded onto a Goldhofer double-wide 16-axle platform trailer. However, the over-the-road trailer was a much larger configuration consisting of a double-wide 24-axle platform trailer. Therefore, the RPV cask was required to be transloaded from the 16-axle line trailer to the 24-axle trailer. The platform trailer was 120 feet long. However, the footprint of the RPV skid was approximately 47 feet long by 12 feet 6 inches wide. As a result, the concentrated weight proved to be too heavy for the spine capacity on the trailer. Emirates International engineered and fabricated steel extension arms that would pin into the end of the skid beams and increase the RPV footprint across the Goldhofer trailer. In addition to increasing the footprint of the RPV cask along the length of the trailer deck, the RPV extension arms also served as the lift points for the cask as well. Because we were required to maneuver the tie-down chains in and around the base of the low-level radiated RPV cask, a radiological technician outfitted the Emirates crew with dosimetry monitors to make sure that the radiation levels emitting from the RPV cask were at acceptable limits. During the lashing efforts, Emirates personnel installed 24 grade 70 chains to secure the unit to the platform trailer. After lashing the load to the platform trailer, the RPV traveled over 300 miles to the decommissioning sites. Along the route, Emert made a multitude of civil improvements, which included repaving an approach to a railroad crossing. Upon reaching the final destination, Emert International again used the header beam configuration to offload the RPV component onto the ground. A jack and slide system was then used to transition the RPV cask onto an engineered concrete foundation pad. Emert International was able to design, engineer, and fabricate all components for lifting the 1,470,000 pound RPV cask, as well as build the components necessary to spread out the load on the platform trailer. The job was completed on schedule without injuries or damage to equipment. Safety Program. Emert generated a work package that included drawings and calculations coupled with a written description of every major task. The work package was approved by the client and the owner. Site-specific safety plans were generated for each segment of work. In the event any changes occurred, Emert was required to resubmit drawings and calculations for the work package. Emert's safety plan was aligned with their internal ISO safety program and was also governed by the San Onofre Nuclear Site Safety Program. All equipment utilized in accordance with the engineering design and intended usage. New techniques demonstrated. RPV extension arms were fabricated to spread the weight of the RPV cask across the longer distance of the trailer deck in order to achieve proper axle loadings. Creative application of old techniques. The header beams and lifting links had to be proof tested to 110% of capacity. Emert International placed a gantry on top of the header beams and then fabricated additional steel hanging links which attached to the top of the gantry. The gantry was extended and the RPV header beams were put into compression for the proof test. Newly designed equipment. Emert International engineered and fabricated climbing jacks and all rigging components to support the RPV cask, as well as fabricate the RPV extension arms to spread the load throughout the trailer. Modification to standard equipment. 4 large header beams utilized to create 2 RPV header beams. The beams were welded together, gusseted, and plated to create 1 large header beam. Degree of difficulty. Multiple attempts had been made to relocate the RPV cask without success until Emert International was engaged. Largest rail car in the world utilized. Heaviest load ever transported on the Nevada highway system. RPV cask dimensions: 47 feet 7 inches long by 15 feet 5 inches wide by 19 feet 3 inches tall. RPV cask weight, 1,470,000 pounds. RPV cask was characterized as Class 7 radiation. Emert employees were required to wear dosimetry equipment that measured radiological exposure when working on the cask. Site characteristics. Emert had less than an inch of clearance on 2 sides of the trailer when placing the platform trailer under the RPV cask. Emert engineered and fabricated hydraulic shoring system that was utilized to support 12 culverts as the RPV cask transitioned over them. Emert International worked in conjunction with the client over the course of 2 years to develop the process to execute the job. The pre-planning and coordination with over 50 agencies for the move ensured the preparedness and professionalism from all parties involved. Commercial terms, limitations. Base contract was firm fixed price. Environmental. All work at the Songs facility had environmental oversight. All Emert employees went through Worker Environmental Awareness Program, which identified protected flora and endangered species that were inherent at the site. Had to navigate loaded platform trailer away from nesting birds that were on the endangered species list. All work was reviewed and permitted by the Nuclear Regulatory Commission.